So for a Solidity Juicebox session today, I'm going to go through some very basic things that project owners may want to know when deciding to use the protocol to manage their funds. In this session, we'll go over how funds come into your project's treasury and under what conditions projects can leave your project's treasury. And we'll do so by stepping through the actual code that gets run when you interact with certain protocol tidbits, either through Juicebox.money, through Etherscan, or however the protocol is accessed in the future. We'll make our way through this fairly large repo here, which is Juice Contracts v3. We're not going to touch most of these files. We're actually going to focus on this JB Payout Redemption Payment Terminal 3.1.2, which is the latest payment terminal that supersedes these other payment terminals. This is the abstract payment terminal that the ETH payment terminal and the ERC21 are based on. So these are the implementations that just take the logic here and scope it down to either ETH or an ERC20. So all the generic logic is in this file here. So I think we should be able to stay most of the time in here. I may hop into, actually I'll almost certainly hop into the single token payment terminal store as well. We'll just use this 3.1.11, which the terminal here will keep a reference of in the store property. So anytime as we're poking through this payment terminal here, we see the word store, we know that we are accessing a bit of information or functionality in this file here. So I'm just going to open it in a different tab if I can. All right, so back to the 3.1.2 terminal. So we'll divide this session into two main parts. The first one is how funds come into a treasury, what exactly happens, what are the strong contractual guarantees. And then we will, at the end, we'll move to talking about what happens or how might you get your funds out of a treasury. And that's paying out to splits of your choosing. And there's also some other methods that are maybe less frequently used currently that should be of interest to project owners who are building these constraints for themselves and their projects. So to start, we'll go through two main functions here. And I guess we'll do a third part at the end where we talk about migration, which isn't necessarily in the common workflow of projects taking in funds and then scheduling payouts from their project, but it's more what happens if there's a new contract that you want to manage your funds from, and how do you get your funds over there. But the two main pieces of functionality here that we'll want to look at are search here for this function called pay, which makes sense and should be familiar from the previous session, where we talked a little bit more about the structure of a payment terminal and how the versioning of payment terminals work and how people can interact with the general idea of a payment terminal from the outside. So pay is pretty important to us here. And the other way that funds can come into a treasury is through a function called addToBalance. So these are the two general ideas that we'll want to grok in this first part of this video tutorial. Pay is the canonical way that you get funds into a treasury. And this will trigger all of the general Juicebox logic as to what happens when a project receives funds. When I think of a Juicebox project, I think of a project that receives funds and then does something as a consequence. And normally it issues a project token outward to someone paying. It may reserve tokens for a pre-configured set of addresses. It may do something that's creative, like mint NFTs or some other piece of functionality that are exposed in the Delegate and data source extension contracts that are more like hooks that people can bring. So all that happens every time someone calls pay. And the other one, addToBalance, it's an option when someone just wants to put funds in a treasury and bypass any special features or logic. So that's also allowed. So if you want to just dump funds in a treasury and not have it mint tokens or not have it go through all of the more like rewarding aspects of paying a project, you can just call addToBalance, which will put funds into the treasury. The addToBalance one is a little bit easier, so we'll leave that one for last, and we'll just dive into the more involved pay call here first. So the moment someone pays your project, they're actually interacting with this external pay function of a payment terminal. It takes in the project that's being paid. It takes in the amount that's being paid, the token that the payment is being made in, the beneficiary of any extra rewards or anything that happens during the payment. For instance, which address gets the project tokens. There's this flag that you can pass, prefer claimed tokens. So a Juicebox project alone will issue project tokens, but track them using an internal mechanism through the JBTokenStore contract, which is in this repo also here at the bottom. So it's not an ERC20, it's not any type of token that you can bring around Web3. But if the project has already issued an ERC20, the payer can specify in line here that the function should just send them as ERC20s. Otherwise, they'll just sit in the JB token store and they'll have to be claimed in batch later by the beneficiary. You can also specify a memo, which gets included in the event that gets emitted in this payment, which can be used in front ends and subgraphs to show notes and other information. And there's also some metadata that the payer can pass in, which will get forwarded to all of the extensions and creative kind of hooks that project owners can provide. For instance, when you mint an NFT by paying a Juicebox project, all the information about what you're minting is passed into metadata, and the metadata is then interpreted by that ERC 721 contract that you'll see a little later on where that hooks in.
Hey, can I ask you something real quick?
Yes.
The claimed tokens going to the token store instead, I haven't seen much of that. Is there a purpose?
Yeah, so deploying a Juicebox project does not require deploying an ERC20 token. By default, tokens are tracked in a mapping here in JB Token Store. I'll do a slight detour here and go and check that out. But essentially, Token Store will keep this balance of kind of unclaimed balance for all the addresses for each project. And then there's a claim function here where once the project later on issues an ERC20, which is a pretty expensive transaction to actually instill an ERC20, then token holders can claim into their ERC20. Another kind of note here is minting an ERC20 and transferring it in the pay transaction is slightly more expensive than just flicking a value in this mapping in JB Token Store. And kind of in service of making the pay function as cheap as possible and the most accessible function possible in the Juicebox protocol, we want to make the baseline routine as cheap as possible so that folks can bring functionality and compose on top of it comfortably. So this kind of allows folks to pay into projects, have their balance mapped and secure. And then whenever someone wants, they can kind of in a batch transaction claim all of those tokens into an ERC20 that the project may not even have issued at the time of the payment, but may have issued in the future.
Okay, cool. Yeah, that makes sense. Thanks.
And then also a project, the protocol makes it easy to deploy an ERC20 that kind of works as this fungible component, this receipt component to projects. But projects can also roll their own contract that adheres to this interface, JB token. So if the project wants some more creative way to do tokens for themselves, they can roll that out, and then the process of claiming will kind of translate into whatever mechanic that they introduce. But the default is a fungible token in token store that does not adhere to any ERC20 standard or whatever that can be brought around Web3. So projects can use Juicebox with confidence that they're not, introducing some other aspect to their business or their project that they don't intend. So the bit of logic here that runs right away is, if you'll remember from last week, this contract here is a single token payment terminal, so it doesn't manage multiple tokens. It's either going to manage ETH or it's going to manage an ERC20. So we're just going to ignore the fact that someone tried to specify a token here. Terminals can be built that are multi-token, so this could come in handy in a future implementation, but we'll just ignore this. If the token is ETH, we're going to just check that the message value here was provided. So there's actually ETH in this transaction. We're going to keep a reference to the balance before receiving the payment. Or rather, this is if the token is not ETH. If the token is ETH, this all happens automatically, since in order to call this, you'll have to send ETH. If it's not ETH, you want to make sure that there isn't a message value. So you want to make sure there's no ETH sent in. And then you want to check the balance before. So let's imagine this is DAI or any other ERC20. You want to check the balance before. You want to then run a transfer transaction to transfer the ERC20 from the message sender into this address, into this contract. The payer must have beforehand set an allowance for this transfer to be to go through successfully. And then we want to just set the amount transferred in to be the amount before, like the current balance minus the balance before. So despite us sending amount here, this implementation of whatever token is being sent could have some fancy logic where some amount actually goes elsewhere. So we want to be safe here and just proceed with the understanding that the amount is current balance minus whatever the balance was before the transfer. Just a little safety check. Otherwise, if the payment is in ETH, we can ignore what the payer said they were paying and just set the amount to the actual ETH amount passed in. This is just some safety stuff that happens before the actual internal pay routine happens. And it's divided this way because this internal pay routine gets called more often in this contract to process different things and to issue payouts between projects, etc. And that all that other stuff won't need this extra safety stuff when receiving a call from the outside.
And so transfer from that, just for anybody watching, that's an internal function?
Yeah, exactly. So transfer from here, it's a great question, is since this is an abstract contract, it implements it here, but it also marks it as virtual, means whoever takes this abstract contract and actually creates an implementation of it, like the ETH terminal or the ERC20 terminal, they'll have to actually roll functionality for transfer from, which is a little different depending on if you're implementing an ERC20 terminal or an ETH terminal. I'll do a quick detour and show you. Transfer from, if you're an ERC20 terminal, you're going to use the canonical safe transfer routines. And if you're an ETH terminal, you're going to use a routine send from one address to another. But as far as this abstract class is concerned, which is going to say, hey, whoever makes of this contract, you figure out what this means, what transfer from should mean. So you definitely want to make sure that you're using a trusted payment terminal, that these routines are implemented as expected. Cool. Now we'll dive into this internal function where all the magic happens. It's from line 1458, line 1337. So a little over 100 lines of code, but I think we can step through it and make sense of what goes on. It's pretty important to, if you're doing your due diligence, starting a project on Juicebox, that you understand what exactly happens when you get paid. You can take people's word for it, but it's nice to know what goes on. I remember when ConstitutionDAO was getting started and trying to figure out how it was going to do its raise. I was in the Discord and offering to help if the project needed to use something like Juicebox. And the thing that really, I think, got everyone excited and motivated to go the Juicebox route was we just went on a video call and a large part of the community showed up. It was a fun open-ended call similar to this one, but where we just went over line by line, like what happens, so that everyone could understand the reasoning behind why something like this is useful as opposed to rolling your own contract or as opposed to using something less decentralized. So we'll do something similar here in hopes that it inspires others to click pay with confidence. So the first thing that happens is we do a quick check to make sure that the beneficiary isn't the 0 address. We're going to assume that you intend some address to benefit from this payment with the tokens emitted or what have you. If you do intend to send like a burn address, to send something non-zero, but misconfigurations happen often with the 0 address. So we just want to prevent that. We want to keep a reference to the current project's funding cycle. So a project's funding cycle defines its current rules. And the rules, involve all kinds of things, like whether payments are even allowed, to how many tokens should get issued during a payment during the cycle. So we want to keep a reference that we'll go and populate in a sec. These like curly bracket things that kind of help. This is more of like a Solidity specific thing to prevent these like dreaded stack too deep errors when the computer is trying to keep track of too many things at once. Basically, this is just saying there's going to be things within this curly bracket that are going to be introduced, and then you won't have to worry about them after the curly brackets close, so you can kind of get rid of them from memory. So this is just kind of a formality. But two of these things that are used internally here are delegate allocations and token count. We'll see how those are populated just in a sec. We'll next want to put together this data structure called bundled amount, which is of type JBTokenAmount, which you can find in the structs folder if you're curious. But it's going to relate a token with an amount with the number of decimals that are present in this amount, since it's a fixed point number, and then the currency this should be interpreted as, in case kind of later on in the Juicebox world, you may be dealing with multiple currencies at once. So there's mechanisms to relate one currency to another in terms of price. So kind of package up what's going on here. In this contract, it's pretty easy since, again, it's a single token payment terminal. So we know what the token is ahead of time. We know how many decimals that token interprets ahead of time, and we know the currency ahead of time. So all that's custom here is the amount that's being passed in. All local variables here have an underscore that lead it. Then all global variables don't. So kind of gives you a little bit of nicety when you're reading. It's kind of hard to find little moments of nicety since a lot of this stuff is pretty context specific. But let's just take this, assume that this is the bundled amount. So we know how much is being paid. This is how much is being paid plus a bunch of information. Then we want to go to the store. As I mentioned in the beginning, there's going to be moments where we poke into the store contract and do some work before coming back out and finishing up what we were up to. All of the funds coming in stay in the contract you're looking at here. So it's the payment terminal. The store is going to help us record information about the payment and keep track of balances. And I guess we'll go check it out. So we'll see what else. But think of the store not as like a shopping store, but like a storage unit. It's going to store information that's relevant to this payment terminal here. So we want to go to the store and record a payment from this payer. Here's the bundled amount. Here's a product ID. Base weight currency this only becomes relevant when we're dealing with a project that has multiple terminals and they may be issuing tokens, different kinds of payments coming in. So it's probably a little too fancy for a first pass of this functionality. In fact, all JB implementations currently only use single payment terminals. So we can kind of ignore this for now. I guess quickly, the base weight currency here is the same currency as the amount. So it's an ETH payment terminal, then the base weight currency is ETH, which means if I'm issuing tokens out of my project and say I want to issue 100 tokens for every 1 ETH paid in, then my base weight currency is ETH. So when 1 ETH comes in, I issue 100 tokens out. Let's say now I have a DAI payment terminal, but my base weight currency on that DAI terminal is still ETH. Then it's going to say, okay, for every 1 ETH's worth of DAI that comes in, issue 100 tokens. So you can kind of keep track of currencies coming in, but still issue tokens outward according to a different base weight currency. So you can kind of keep a standard issuance pattern across multiple terminals, if that's how you want to run your project.
I have a question.
Jump in.
The base weight currency and the store, I guess store, is that instantiated in the constructor?
It is, yeah.
Or when the terminal is deployed? Okay.
But both of them are in the constructors. When the terminal is deployed, all of this static info gets passed in. Yeah, so since it's a single payment terminal, you get the token, the decimals, the currency, base weight currency, payout splits group. That's another thing that we'll visit here in a sec. And then all of like the operator store projects. Yeah, all this stuff.
Okay, cool.
Yeah, and that's constant references that this payment terminal needs. Back to where we were. Cool, so we're gonna go and now take a look at record payment from, which might be useful. I'm trying to think here. Yeah, let's just go here and follow the train of thought. So it's in the file next to it that I had opened up earlier. So here's all the information we passed in from the terminal. And what this is going to be responsible for returning is the current funding cycle, the amount of tokens that should be minted, an array of delegate allocations. So delegates are custom contracts that projects can install hooks within. So like a delegate allocation might have information that says, go to the NFT delegate and send this amount of ETH from the payment, like takes a little bit of ETH and don't put it in the balance of the project, but instead send it to this delegate. And then here's some other data that you should know. That's kind of what a delegate allocation is. So we'll make our array of delegate allocations and return it to the terminal. And then we can also reshape the memo if there's some other additional context we want to add in that memo. This is going to be a little bit more involved. It starts here, ends here, but we'll again go through it. There's going to be a few other points where it pivots out to other contracts. I'll explain those.
One quick thing, this looks a lot like the ERC 721 delegate, like this portion where it's recording the payment. It looks a lot like the Mint recording from that contract store.
Yeah, and in fact, bit of logic. You'll see where it gets called. It gets called back in the terminal once this returns. There's a different set of, like, here's where the data source gets called, for instance.
Yeah.
So you'll kind of see where it plugs in. It has a few differences, although you can also imagine, like, the core Juicebox functionality when it receives the payment is to mint project tokens back out. You can imagine that piece of functionality as a delegate that's like baked in to the protocol and kind of available for free. But it also has a few properties that are a little bit more kind of fundamental. But you can think of certain bits of this as being, implemented as a delegate later on. But I think once we go through it and you kind of get a sense for where these hooks hook in, how they relate will start making sense, hopefully. First things first, go to the funding cycle store and get the current funding cycle of this project ID. So now we have a reference to all the rules. Make sure it exists. So if the project doesn't have a funding cycle yet, then that project doesn't exist. So go ahead and revert. And if anytime something reverts, the whole payment reverts. So these are all safety checks. If the funding cycle has a pay paused rule set, then go ahead and revert. Otherwise, let's keep going. So the first thing we're going to do is keep track of a weight. Weight is the term that's used to determine how many tokens get issued per unit of payment coming in. So a larger weight means more tokens get issued per ETH payment coming in. Smaller weight means less. 6 point with 18 decimals. So specifically, a weight of 1 million with 18 zeros afterwards will issue 1 million project tokens for 1 unit of payment coming in. Unit of payment in terms of the base weight currency. So keep a reference here. We'll populate it. The weight is set by, so this is the first kind of extensible chunk of code. If the funding cycle has this rule set, use data source for pay, and the funding cycle has a data source contract attached, then what we want to do is go and get the weight from the data source, populate this memo that will return from the data source, and get delegate allocations from the data source. So the data source is going to basically provide the data. It's going to be the source of data. Otherwise, this contract will be the source of data. And we're going to say the weight is the standard funding cycle dot weight, which is the number that kind of gets auto decremented with what's called the discount rate in the protocol. I think some clients use issuance reduction rate. So we're just going to take it directly from the funding cycle and then set the memo as exactly what was passed in. And we'll notice that if we do go to the data source here, we're going to pass in this data parameter, which is just a bunch of context, right? So which terminal received the payment, who's paying, how much, what project, during what funding cycle, who's the beneficiary, what's the funding cycle weight. So oftentimes a common pattern is in the pay params and data source, it'll just return the current weight. So it'll just forward what was passed in and you'll get the same outcome as if you were to set it here. Data sources can do something more creative, but you can just pass it along. The data source will also know what the reserve rate is and the memo and metadata. So this is all stuff that it'll get in line. It can go and fetch other stuff in the Ethereum smart contract world if it needs more information to execute, but here's just a bunch of context. So once this is done, we have all of our information. We have determined how many tokens we want and what we want the memo to be. So all we got to do now is do some balance manipulation. So make sure we're tracking how much new funds we have. And then we want to normalize the weight given the base weight currency, which is what I was talking about a little before. But for the most part, this bottom chunk kind of gets ignored since usually the currency is the same as the base weight currency. So we'll jump back here and do this little section. So the first thing we'll want to do is assume that the difference of balance is the amount that was paid in, right? So assuming before the payment, there's balance A. After the payment, there's balance A plus amount value, and keep track of this diff. If the data source passed in delegate allocations, which defaults to an empty array by the way. So the reason that you don't have to set delegate allocations to an empty array is because it's already kind of preset here as an empty array. If there are delegate allocations, what that means is maybe some funds that are coming in aren't going to go to the balance, that are actually just going to be forwarded to the delegate. So what we'll actually want to do is loop through all the allocations, keep track of the delegated amount. If there is a delegated amount, then we want to check it against the balance diff and update it. So if you're trying to allocate more than what's paid, that's no good. Otherwise, let's just go ahead and decrement the diff here so that we actually aren't going to keep that balance here. We're going to send that off to the delegate. So if there's no amount being paid in, then we can just go ahead and forward it, kind of forward the result out to the payment terminal who called us. Very rarely will these two blocks of code happen together. Actually, like if not ever. That's why it might seem confusing at first, but essentially if you have no value coming in, then you don't have any delegate allocations available anyways, since the balance diff is 0. Let's just assume they're kind of, or they're not mutually exclusive and they both can run. We're good to go if there's nothing being paid. Otherwise, we want to actually store the balance difference. So we want to make a note of the fact that the project now has a greater balance than it did. Similarly, if there's no wait, if we're not responsible for minting any tokens, go ahead and return. Otherwise, we're going to do this quick kind of proportional arithmetic to normalize the weight and return the token count as the terminal should have to actually do the minting. So you'll notice here, we didn't actually, all we stored was the balance. We didn't mint any tokens. We didn't call any delegates. We didn't do anything, interact much with the outside world. We just went to the data source, said what's up, and then stored some difference of balance here.
So the delegate allocations, when this is checking to see if basically what might be missing here as context is that basically the payment terminal is checking to see if there's a data source configured.
Right. Yeah. So this is the store contract, right? So if there's a data source, then the data source is telling us that some funds, the final destination of the funds may not be the project's treasury. Some of those funds may be forwarded into the delegate contract or a set of delegate contracts, in which case this delegate allocations will be populated from the data source in response to pay params. So data source.payParams is the hook there. If there's no data source, then this all gets skipped, obviously.
So how are the data sources stored here? I guess I just haven't seen that.
Yeah, the data source is an address. There's a single address that's attached to the funding cycle. So once you know the funding cycle, you know the data source.
Oh yeah, that's right. Okay. Yeah. Okay.
So it's dynamic. It's the data source can change on a funding cycle by funding cycle basis.
Right. Right. Cool.
Yeah. So that's passed into when a project owner reconfigures their project's funding cycles, they specify this. We'll leave that for a different video, but that's definitely an important piece of context.
Cool. Thanks.
Cool. Let's hop over to the payment terminal. So we have all this information we got back. We know the funding cycle. We know how many tokens we should mint. We know the delegates that we should call on. And we have the memo to forward to the event. Everything else should be pretty self-explanatory and should follow. Now we're just actually doing the stuff. If there's a token count, we're going to go to the current controller of the project who's responsible for minting tokens and go ahead and execute the mint. If no tokens, obviously you don't need to do that. If the beneficiary token count, which is a result of this mint tokens of, and if it's not called on, then beneficiary token count is the returned value of this payment. So the return of the payment is how many tokens got minted for the payer. So it defaults to 0 if you don't specify it. Otherwise, we store it to the actual amount. If that amount is less than the min tokens returned is passed in from the outside world. I might have skipped over that earlier, but one of the parameters that gets specified when the payment is made is how many tokens are expected to be minted for the beneficiary. In the case of schemes like the buyback delegate, this can be important to kind of specify, or just in a normal Juicebox context, to specify, like, I'm making a payment, I think I'm going to get this in return. That way, in case for some reason the data source says you get less than that, then your payment will just fail and you won't kind of deal with that unexpected consequence.
That would kind of keep you from experiencing too much slippage with the buyback delegate, because the buyback delegate could just be configured for like any arbitrary amount of slippage.
Yeah, I think I misspoke a little bit when I said buyback delegate. There's that a lot of that slippage control happens in the metadata. I think a better frame of reference here is thinking like, what if I make a payment, it gets stored in the mem queue, in the mempool, I don't have a high gas, and the funding cycle rolls over, and I now get fewer tokens than I expected, or maybe there's paused payments or something in the next funding cycle. In the case where I was expecting to get more and I got less, then my payment would just fail. I wouldn't have the consequence of kind of I paid less gas with an expectation, but it got honored later when I got kind of less than expected.
Gotcha. Yeah, that could be useful for a lot of things. Thanks.
And then this chunker here is doing work to actually fulfill the delegate work. So if delegate allocations were specified, we're going to chunk up all the data. Again, just a bunch of context for the delegate to have. And then we're going to loop through each of the delegates. So if some funds are from the payment are being forwarded to the delegate instead of added to the balance of the project, we're going to do a before transfer to call, which works similarly to that internal function from earlier that's implemented in a custom way from anyone who implements this contract, ETH or ERC20. They're going to have different things here. In the case of an ERC20, we can imagine before transfer to sets the allowance so that whatever the delegate receives, the delegate has permission to pull funds. It's going to set some information here, and then it's going to call did pay, which is the delegate hook that's going to be forwarded ETH if ETH is the token being paid in. Otherwise, all the information is going to be in data for the delegate allocation to work with. And it's going to do this for every delegate allocation specified. And then we're going to emit the event with that memo we've been constructing along the way. Most often, this is just going to be passed straight through from the top, but the data source has an opportunity to play with it. And this can then be indexed by subgraphs or what have you to decorate other databases that aren't on-chain. This is the bulk of pay. So this happens every time you receive a payment. It's designed to be as cheap as possible while still affording some bits of flexibility where projects can roll their own pieces of functionality through delegates and data sources. All the reserved token allocation logic gets handled in the controller during this mintTokensOf call. And that reserved token allocation is also very price aware. It doesn't send tokens out to everyone in the reserved list right away. It just kind of stores that balance that can later be fulfilled. So this whole thing it's fairly long in kind of logical sequence, but there are fairly few storage operations here. There's that one in store that actually tracks the balance, which is sensible. You need to keep track of how much is sticking around. And then there's the mintTokensOf, which tracks the balances of the tokens that are issued for the beneficiary and for the reserve token recipients. Other than that, it really comes down to, does the project have other fancy stuff it wants to do? If so, the bulk of the cost happens here, like minting NFTs or playing with other ideas. So hopefully there's still a lot of space to play with ideas of what happens when you get paid without being burdened by kind of baseline gas costs. Any questions with pay? Otherwise, we will go to add to balance. And I'm thinking we may just chunk up the session and do inbound payments this time around and then outbound payments next time around.
I have one thing. Just for context, the ERC20 mints for the projects are happening via the controller after a payment is received, correct?
Yes. So the controller here, once the store lets us know how many tokens are being issued or should be minted, the controller here does the mintTokensOf calculation. And actually, that's probably worth diving into. So I'll go through mintTokensOf briefly here, and it's going to honor this prefer claimed tokens flag. So if you are minting tokens and you prefer them to be claimed, this will handle that. So you'll notice here, this depends on you go to the directory and we're going to check what's the current controller for this project. So the project can also change its controller over time. The controller is the one contract that has permission to actually access the token store or the funding cycle store, these more like hidden contracts that don't really have a lot of outside world interaction. The controller really manages interactions with those. So here we're going to go to the controller and try to mint tokens of. So I'm going to hop into mintTokensOf. It's fairly short. So what it expects is project ID, the number of tokens being minted, who the tokens are for, and a memo that's optional that will get included here. The prefer claim token flag, and then also a flag indicating if reserved tokens should be used. mintTokensOf can be called directly from the project owner, or it can be called from a current payment terminal of the project. So the bulk of this initial work here is this require permissions allowing override call that's kind of a standard auth check in the Juicebox world. Basically saying, if you're the project owner, you're good to go. Here's a project ID to look within. Here's the operation. So the project owner can give other contracts permission to operate this call on their behalf. So you can imagine some other fancy thing that someone does that its only job is to mint tokens of kind of outside of the payment, the inbound payment realm. And the project owner can do that just by specifying this specific operation and give the operator permission. This allowing override bit of this require permission means the last call here is a flag that overrides everything else. So if this is true, then the payment is still allowed. In this case, what we want to do is allow, or rather, if the message sender is a payment terminal of the project, which is the case in the case of pay, or if the message sender is the data source of the current funding cycle of the project. This is allowed here out of convenience. So if you're building a delegate that is in fact also a data source, if you're doing it all in one, then you don't have to specify operator permissions for your delegate since it's allowed here. The reason that this makes sense is because the data source, as we recall here, the data source is already telling us how many tokens to mint. So the data source has power to determine like how many tokens are minted. So we're just going to go ahead and give it permissions to make this call on our project's behalf. So definitely be very careful when adding a data source to your funding cycle. It has a lot of power in determining what happens when payments come in, but also it can mint at will. So if you're not, don't set your worst enemy's ETH address as your data source. Yeah, so up here, yeah, if there's no tokens, if someone sent 0 here on accident, then there's nothing to do. So go ahead and revert. I think that's it. Yeah, so let's go down to the actual storage magic. First, check if the funding cycle has minting allowed. Your projects can pause minting, in which case this command would fail. But if the message sender is not a terminal or the data source, the current funding cycle must allow minting. Cool. So this is basically saying minting is allowed. The mint is coming from a payment terminal or a data source. Otherwise, if it's project owner minting directly, minting must be allowed. So a flag in Juicebox is allow owner minting. So if a project allows owner minting, then project tokens can be minted whenever payments come in. That's the standard routine. Then project owners can also go in and mint at their discretion. So that flag has to be on in order for project owners to be able to do that. Despite it passing this permission check here, we're going to just catch it here. And the reason for doing this is like we don't want to, so we just want to make sure we're not paused, or that minting is in fact allowed. Reserved rate. Okay, so now the reserved rate logic comes in. If we intend to use the reserved rate, which is a flag that's specified here, which is a flag that in the pay call here, we can expect is true, since payments, we expect reserved tokens to be minted. So if user reserved rate is true, then go to the funding cycle and find what that reserved rate is. Otherwise, set the reserved rate to 0. This lets a project owner mint tokens without affecting the reserved rate or with affecting the reserved rate if they want to bypass, if minting tokens is allowed. We also want to check if prefer claimed tokens is true, go ahead and set it. Otherwise, one of the rules that a funding cycle can have is the project can basically force issue into their token, their ERC20 or whatever. That flag is called prefer claimed token override. So a project can set a funding cycle in motion that forces the claiming of the tokens so that every payment doesn't have to have this flag specified, and they can just bypass the unclaimed route altogether. It's going to be slightly more expensive per mint, but that's fine for a lot of people. And then we want to just do the right accounting here. If the reserved rate is not the max, that means there's going to be some tokens that go to the beneficiary. If so, let's go and find out how many, right? So take the token count, multiply it by the amount that doesn't go to the reserved rate. So the max minus reserved rate over the total max. That gives you the beneficiary token count, and then go to the token store and do the minting. The token store mintFor will actually do the storing of information in itself or in the token if prefer claimed tokens is true. Then if there was a reserved rate, we also want to track how many tokens are reserved for that project. and that is the token count minus the beneficiary token count. So anything remaining is reserved. And then this token reserved token balance of gets decremented when reserved tokens get distributed. And then we want to emit an event here to let the outside world know that tokens have been minted.
I have a quick question. The token store, is this serving as an ERC20 as well, or is it like just attached to the token store?
It's a global token store for all projects and all accounts.
Oh, okay. Okay.
Yeah. So there's one token store, and it stores relative to project ID. When a project deploys, it's not deploying any new contracts. Everything in the Juicebox world are mappings referenced to project ID. So it kind of can allow for these single implementations to handle information across the board.
Gotcha. Okay. Yeah, I guess I just haven't seen the token store contracts, and I haven't seen, what was the other one? Maybe it was the funding cycle store? I'm not sure.
Yeah. Funding cycle store and token store. For instance, tokenstore.mintFor. I'm just going to go and look at this quickly to show you. This can only be called by the controller of the project ID. So this has like project owners can't go here, and no one can go here and call this directly.
Yeah, that helps a lot. Just making sure like I knew they weren't separate contracts and that everything's still operating on associating by IDs. Yeah, that's great. Cool.
The logic is chunked up in these abstract ways, like token functionality, funding cycle functionality, but hopefully it helps reason about and separates concerns. You know, like what's like everything that happens in funding cycle store has to do with like scheduling and time and like storing rules that apply at different time frames. Everything that happens in token store has to do with just these balances of tokens and claiming stuff like that. It's obviously an abstraction when you go into programming world, but pretty stoked with how the whole architecture turned out once we played with it a bunch and kind of saw these patterns turn up and this like reusability made possible.
What I'm curious about too is JBPrices. That's another contract I haven't seen.
Yep, JBPrices is a great deep dive that we should do a different episode.
Okay.
We haven't used it much, mostly because we've only facilitated single token payment terminals, and projects mostly just operate with one payment terminal. So there's not a lot of pricing action happening, like figuring out how one price relates to another. The one place that is used is you can set your treasury to be like dollar denominated, for instance, despite ETH being the currency being used. So you can set like a distribution limit of $100, despite your currency being ETH. So JBPrices helps to negotiate that rate in real time.
Is there an oracle for the ETH price?
Yeah, so it then takes in, you can add a feed. I'll go kind of do a cursory overview here. JBPrices. So you can ask price for the currency, the base, and the number of expected decimals. Then the owner of this contract here, which is JuiceboxDAO, can add feed for, and that's an iJBPrice feed. iJBPrice feed is, as you'd expect, just kind of a wrapper for getting a current price. And so you can roll a Chainlink oracle,
okay, cool.
time-weighted price oracle. Currently, the one that we use is just an ETH USD Chainlink oracle, and that's kind of stored at price feed. Now I'm clicking around. Where is it stored here? Feed for currency base. Yeah, so you kind of can see, like, given a particular currency, which is just an enumeration. Bear with me as I just hop around for a sec. JB currencies. ETH is 1, USD is 2, for instance. Okay, cool. So if I have JBCurrency.eth as 1 and JBCurrency.USD is 2, then I can store a price feed relative to those. And I can also add any number of currencies to this namespace and store price feeds that are relative between these currencies. There's a lot of poking that we still need to do on the price feed layer, since we're not adding a lot of price feeds. We don't have like a large concern currently with managing tons of price feeds that we may have once we enter the world of multi-terminals and projects accepting funds of all kinds. But for now, this is fairly straightforward. You can add a feed for a currency and a base currency, and they get stored, and then contracts can find prices relative to different currencies here. Here's a very simple implementation.
Sorry if I derailed you because I completely forgot where we were.
This is great. No, this is all very relevant information and very relevant to people. Anything that is relevant to people starting projects or paying projects, like all these questions are very, very good. So IJB price feed is kind of that standard, just needs current price. This is a JB Chainlink V3 price feed. That's just going to do the Chainlink logic, right? It gets initiated with a Chainlink feed. In this case, it's a ETH USD one. And there's just some checks to make sure prices are current enough to work with. And then it returns what it expects here. But yeah, looking forward to entering the world of prices, which luckily JB has been operating in ETH land until now, which is really nice because we can kind of isolate complexity and we can kind of assume some things are steady and sturdy. We've kind of assumed the prices world and ERC20 terminals have kind of been steady. We're not opening up that can of worms yet, so we can make some progress with risk mitigation and some extensibility components. But very soon, once that side of things steady, then it'll afford us the ability to really have some fun here. I think this just leaves us with going back to the top and checking out addToBalanceOf, which is really straightforward. If you want to dump funds into a project out of generosity or because you're a project owner and you want to return funds to your project because you withdrew it to bid on an auction and you lost and now you want to put funds back so that everyone can redeem, or you're a project and you want to bootstrap your project with some money in it, it relates to tokens in some way or another. You can do so through addToBalance, which would bypass all of the other fancy stuff. So you can expect this call here to be very simple. A quick detour. There are two external addToBalance calls. They differ just by one parameter. So this one here is going to call this other one here and just pass this false flag. It's going to forward everything else it gets, and it's going to pass this false flag. So we got to check out what the hell this false flag is. This false flag is should return held fees. So JB also has so when you withdraw payments from a treasury, it incurs the JBX membership fee. And so that will take that membership fee and pipe it into JuiceboxDAO's treasury, which is project number 1, uses the same schematic here. And it'll do so via pay function, which we just visited, and it'll issue JBX in return to the project owner paying the fee, right? If you've fundraised a bunch of funds and you've pulled it out to then go and bid on something, and then you lost the auction and you want to put your funds back, there's a funding cycle rule that you can instill that's called hold fees. If hold fees is on, then whenever you do that withdrawing of funds, instead of actually processing the fee into the pay function to issue JBX, instead that fee is just kind of going to be held outside of both your balance, the project owner, and JuiceboxDAO's balance. And it's going to wait either for JuiceboxDAO to process the fee, which it has access to, or for the project owner to process the fee, which everyone is somewhat incentivized to do so sooner because the price of JBX is kind of slowly decrementing with its discount rate. So you probably want to process it soon to get more out of your JBX from paying the membership fee. But if there's a chance, you may want to put the funds that you just withdrew back into the project to make all the funders whole. You can addToBalance with this flag as true, in which case it'll revert the held fees and the full amount will be made available to the treasury. So this terminal doesn't enforce fees if you withdrew and then you're putting funds back in, if you have that flag on. JuiceboxDAO can at any point go in and process the fee, so it reserves the right to do so if you're using this payment terminal. But this was a learning that we had from early days when SharkDAO was using Juicebox to bid on nouns and had a few missed attempts before finally succeeding. So this is nice if you're doing fundraisers and whatnot.
They would kind of like miss a bid and then have to add back to their balance. But the refund held fees, I started looking at the domain DAO proposal because I don't really know what that's about either.
Yeah, it's unrelated. It's maybe like kind of related. I think most projects that are going into a fundraise with the idea that whoever's managing the project wants to do something with community funds, and if they're not successful, everyone should be made whole. And from JuiceboxDAO's perspective, in instilling this held fees component, we're saying we only want to charge the membership fee if you're successful in your bidding. If not, fundraise, join forces, And then if you fail, that's okay. There's a clean way to put the funds back into the treasury such that everyone's token redemptions give way to 100% refund of what was put in.
Okay.
So held fees is a way to actually do that, adding the funds back into the project in a way that will take that fee payment that was set aside at the time of distributing funds from the treasury into whoever's managing interaction with whatever auction. But importantly, the project must be set up with that held fees flag as true.
So payouts incur a fee, but this is adding to the balance of the project.
Sure. Yeah. So payouts, imagine the flow as, let's say, everyone on this call is getting together to bid on a golden banana. We each put in 1 ETH. We all agree that I'm going to manage the bidding for the golden banana. So everyone puts in an ETH. And then we schedule the payout, right, from the treasury to myself. Let's say there's 4 people on the call. I'm not looking at the Discord, so I don't know, maybe people are here. And when I click distribute, I won't get 4 ETH. I'll get 4 ETH minus the 2.5% fee, right? So I may end up with 3.87 or whatever, right, in my balance. That difference between 4 and the 3.87, it was not processed in that transaction. Normally, that fee is processed in the same transaction as the distribute, and that goes through to the JuiceboxDAO and issues JBX. If held fees is on in a funding cycle, that difference gets set aside and tracked in this contract. If I scroll up, there's a storage property that shows all the held fees for projects. Now, let's say we don't get the golden banana, then I can put in the 3.87 back into the project via this call here. I can say should refund held fees as true, so that what actually ends up back in the treasury is 4 ETH, not just the 3.87 that I put back in.
Okay.
Kind of makes sense?
Yeah. Is there a potential for abuse here, or am I still thinking about it wrong?
I mean, there's always potential for folks always having held fees on, but then what they'll have to do then is, let's take JuiceboxDAO's instance, for example. Like, we're spending funds from obligations, from proposals, and we'd all have to get together and decide that we all want to put our funds back into the treasury to get our fees back. Or we have to generate enough revenue to basically cover and put funds back into the treasury to kind of like cover what we've been spending, right? So
I see.
theoretically,
Yeah.
you can run a project forever if you manage to always pay your debts in a way, right? So whatever you took out, if you manage to put it back in every single time, like before JuiceboxDAO kind of catches wind and like sends the transaction to actually process the fee, then maybe you have like some thing going for you. We're all well aware of this. It's pretty fringe. And even in that case, like, we know that everyone's better off from paying the fee sooner rather than later. And with buyback delegate in place, everything is kind of designed such that fees aren't necessarily a bad thing. Like, we're all somewhat working together here. And a lot of this infrastructure is made possible through it. So a lot of it is the communication exercise of like, what is a fee in Juicebox land? It's kind of a different thing than what we assume fees to be. So we kind of have confidence that functionality like this that needs to be made out of convenience for certain types of projects like auctions and whatnot should be made available to everybody. We're not going to just like do a proposal each time someone has some way to think about this. But this mechanism is a good middle ground where everyone is somewhat incentivized to play the game on their own.
And you said somebody from JB could like catch wind and they would be calling, would it be the cycles payout, or is there some other function?
Yeah, so there is a call to, so processFees is you send the project ID, only the project owner can call it. So the owner can call it anytime, and allowing override again. So the owner of this contract, which is JuiceboxDAO, can also call it for any project. And that'll actually go through the fees and just process them.
Oh, cool. All right. Well, that's an interesting edge case, yeah. But it makes sense why you guys have to enable that for things like SharkDAO.
Yeah, lots of learnings. And the mechanism as a whole is like, it's really cool. I'm pretty grateful to be diving deep into the weeds because some of these architectures I think are like really, really dope and pretty powerful without involving a lot of management or overhead from a DAO's perspective. These things can kind of just run on their own. And ultimately, folks can fork these terminals and run them totally feeless if they want. And it's up to clients to decide which terminals to really care about. It'll only really all make sense if the fees are worthwhile for everyone involved. Otherwise, it's fairly easy to move on and take advantage of the rest of the infrastructure. So hopefully we find like that good middle ground of like, there can't possibly be rent seeking, but we still can build and be supported for building things that we care about and that are important to
Yeah.
folks. It's definitely an alt take on like the whole public goods rhetoric, right? Which seems to kind of like bypass fees altogether or try to like marry it with gas and some L2 kind of sequencer thing. This is basically saying like fees are good. Like, if charge a damn fee if you're doing good work that people care about, and like tell the story in a way that's like the fee is actually the reciprocal action from the fee is giving you access to at least govern, if not actually redeem for the cumulative pie as it's being built.
Have you heard about contract secured revenue?
Maybe I've heard about it in a different verbiage, but do share with me more.
I don't know a whole lot. It's mainly like if you deployed a contract that was used often, you would get a portion of the sequencer fees because you're generating activity on the network, basically. So like,
Oh, cool. Is this
yeah,
Canto? Did Canto do something like this?
Kanto does it, yeah.
Yeah, cool. I love experiments in this vein. I love kind of thinking about business models and finding sustainability therein. I think it makes a lot of sense. The thing I'm most excited about in this whole Web3 world, of Juicebox world, and extended to Canto and other projects is figuring out what it means to do work sustainably over time instead of needing to fall trap to our traditional models.
Yeah. I think it'll happen eventually. It's just like time and
Totally.
attention.
Totally.
Yeah, but I think Kanto's doing that, and then Public Goods Network is also doing that. But I don't know too much about PGN, but it seems like a
Yeah.
cool scheme.
I think we could run Juicebox on all those and kind of layer layers.
Yeah, probably for sure. Yeah.
Cool. All right, let me just wrap up with this call and then we are good to go. And then we'll check back in next week for the actual outbound payment functionality. To start off, same thing as pay. Just make sure the funds get in here. If it's ETH, set the amount. If it's not, transfer it in, and then call this internal function, which is really simple. First, check if we need to refund held fees. If so, go ahead and do the refund and then keep track of any fees refunded. And then we're going to go back to the store to change the balance. So here we're going to go record added balance for, and it's the amount passed in plus the fees refunded. And then we'll emit the event. And just for completion, we'll go through here. This is tiny. It's just going to do the addition here and then return back to the terminal. And that's that. That's how you interact with projects from a payer's perspective or from a project owner who wants to add funds to their project's balance. And we'll leave the distribute payouts call for next week. And then we'll also leave migrate for future week. So we space these out. But hope this has been informative and helps to answer some questions from folks who are thinking about using Juicebox for their treasuries.
Do you think you'll go over splits at the same time as
Yeah, that's
distributing?
next week.
Okay.
That's next week for sure. Yeah, that's the heavy chunk of what the distribution entails.
Yeah.
So we'll talk about that at length, and then you'll see the extensions in the split side as well. Here you saw some extensions in the pay side, so the data source, the delegates. Next week we'll see what does this split look like to an address, which is a pretty common thing. A lot of protocols have like splits to different addresses. In the Juicebox world, you can split a payment to or payout to an address or to a Juicebox project, in which case if you split to a Juicebox project, you also have to specify who benefits from the pay call, who's the beneficiary. So in the split, you kind of already bake in some parameters that will get called on those pay calls. And you can also set splits to this extension, a pay allocator, which is just a contract that adheres to a very simple interface. It just says allocate. So if your contract has means for being allocated funds directly, then it can be made into a split that gets bundled into the distribute call. Little preview. We'll go through it next week. It's fun. It's powerful. There's a lot to do there, and we have been using them for migrations quite a bit. So when migrating from V2 to V3, for instance, of the protocol, V1 to V2, you set kind of an allocator contract that can move funds across these different versions since they all use different directory A's. Because if you're calling it based on project ID, they have to share a directory. So an allocator is great for them if you need to bridge to like a different version of Juicebox altogether. The goal of Juicebox is to not need these major versions over time. We can kind of eventually stabilize and be in a very like risk managed state, but we have affordances to be able to move if we need to, and give projects the ability to move themselves if they need to, or if there's some issue that's found or something. Alrighty, y'all. Good fun. Thanks for listening in. Thank you, Matt and Briley, for organizing and nudging this series on. It's been fun. And thanks for the excellent questions, Nowonder. These are like really, really good questions, and I'm super stoked that you're getting the kind of the full context of what's going on. Excited to see what you make from it.
Yeah, I'm getting there. Thanks, man. Thanks for having me.
Thanks so much, Jango. This has been great. I'm looking forward to next week.